Hello, I want to work this problem. It's number 3 from the online work, but it's number 17 of the book, or it's pretty equivalent to number 17 of the book. So this is the shape we're talking about. It's this wedge, and it's going to be rotating around the x-axis. So it says use the shell method to set up and evaluate the integral that gives the volume of the solid generated by revolving about the x-axis, and y equals 1 over x. So what we have is really two things to look at. Let's see if I can draw it here. Bear with me, I'm using a new computer and it's a different type of sensitivity. So here's our little wedge or slice, and we have a point where it, let's see if I could change this to a, there we go. So let's cut it right along there. So, and then we have essentially this, as you can see that yellow there. There's an approximating rectangle, and here's an approximating rectangle. So if you recall how they go, we're looking at, instead of these, normally they're vertical, which then we have top minus bottom. Here we have left, or right minus left, I should say. So in this first part, we have the curve part. Our P of y is still y. Our H of y is going to be the right side, which is 1 over y, minus the left side, which is 7. Down here, our P of y is still y, and our H of y is again the right side, which is 8, minus the left side, which is 7, so it's 1. And so our volume is going to be 2 pi times the integral from 0 to 1/8 of P of y, which is y, times 1, which is y, dy, plus 2 pi times the integral from 1/8 to 1/7 of this y times 1 over y minus 7. So that would just be 1 minus 7y dy. So the volume is going to be equal to y squared over 2 from 0 to 1/8. I forgot my 2 pi. Plus 2 pi times y minus 7y squared over 2 from 1/8 to 1/7. I'm really sorry how sloppy that looks. Okay. So our volume over here is going to be 2 pi times that 1/2 from under that y squared times 1/8 squared is 1/64 minus 0 plus 2 pi times 1/7 minus 7/2 times 1 over 49, because that's our 1/7 squared, minus 1/8, my 8ths look like 9s, 1/8 minus 7/2 times 1 over 64. Okay, so we're looking at here pi over 64 plus, then over here we have 2 pi times, so it's 1/7 minus 7/2 times 1 over 49. I'm just going to put that in the TID9. 1/7 minus 7 divided by 2 times 1 divided by 49. And that gives me 1/14 minus, and then we have 1/8 minus 7/2 times 1 divided by 64. 9 over 128. So it's pi over 64 plus 2 pi times, if I do 1/14 minus 9 over 128, I get 1 over 896. Okay. Now if I factor out my pi, I have 1 over 64 plus 1 over 896. That's going to be that should be 2 over 896 because it was 2 pi. One over 56. So it's pi over 56. Okay. I hope that makes sense.